Hey guys, just trying to go ahead and record the video notes on the rock types for you guys. I cannot remember which page was first, so I'm just going to work in alphabetical order for you guys. To go over the notes for those, it helps to hear. So the first type of rocks is our igneous rocks. So igneous rocks form when we have lava or that cools and crystallizes. Remember, it's lava inside the earth. When it erupts from a volcano or a hot spot, it's magma. But when it cools, it forms an igneous rock. All right, so the type of igneous rock we get will depend on the composition of the magma. In other words, what type of minerals or elements are inside that magma. Of all the compounds present in the magma, silica is the most abundant and has the greatest effect on the magma characteristics. We have three types of magma, basaltic, andesitic, and rhyolitic. Not really know about this one too much. It just kind of shows you how the silica content of different types of rocks, and the more silica towards the bottom right. And then the ones with less tend to be higher temperatures, crystallize first, and down to low temperatures last to crystallize, which means to become a rock and form its mineral grains. All right, with our igneous rocks, within color, there's two different types. We have mafic and felsic. Felsic is our light-colored rocks. They are less dense. They have a lot of aluminum, potassium, silicon, and sodium. An example of this would be granite and rhyolite. Mafic tends to be dark-colored. It has to be lots of calcium. It has a lot of iron, magnesium. It's low in silicone. An example would be basalt and gabbro. You can tell the felsic is light colored and mafic is dark. All right, classification depends on the mineral composition, the crystal size, and the texture of the rock. We have two main classifications, which are based off how they form. Intrusive rocks form inside the Earth's surface, and extrusive rocks tend to cool on the Earth's surface. So intrusive rocks, they form inside the Earth, so they're going to cool a bit slower and tend to have larger mineral crystals, which we call coarse-grained. And extrusive tends to cool on the surface of the Earth, which means it's going to cool more quickly, and then be more of a fine-grained or smaller-grained rock. With texture, we look at size, shape, and the distribution of crystals. So here you can tell a difference between coarse grain and fine grain. Most easily to see is between the obsidian and granite. Fine grain, you can't really see the crystals, or they're very small, like in the rhyolite. The granite, they're larger grains where you can see visible crystal structure. So that would be a coarse grain rock. So again, if it cools quickly, it's going to be small crystal, for example, the rhyolite. And then if it cools slowly, it's a larger crystal. We have two other rock textures. One is called porphyritic. That's when we have a large, well-formed crystal surrounded by fine-grained. We need to fix that. Fine-grained crystals. So if you can tell, we have large, coarse-grained right here on the top right in this picture, and then in the black part, you can't really see the crystals. So kind of think about like pores, like large pores and small pores. That helps you. And then a vesicular rock is it's when the magma contains dissolved gases. So when it's cooling, the gas bubble, it pops and it forms holes in the rock. Pumice that we use on our feet when you get a pedicure, that is typically has all those holes, so that is called vesicular in texture. Other resources or ways we can get these igneous rocks. Vein is a distinct sheet-like body of crystal within a rock that forms when the mineral is deposited through precipitation of that element or mineral. Pegmatites, which are ores of rare elements such as lithium and beryllium. Kimberlites form deep in the crust of the mantle and form under high pressure, for example, diamonds. Remember, coal after a long time, it can become a diamond. It's called a kimberlite, is its technical type of igneous. They're often used in construction. All right, let's just review questions. Go through those on your own time. I'm going to go on to metamorphic rocks. So metamorphic rocks form because of heat and primarily pressure. Those are the two main processes that form a metamorphic rock. Extreme heat, but it's not enough for the rock to melt. That would be and turn into magma. That would be an igneous rock. So it's hot, but it's not quite as hot. But it does have extreme pressure from underneath the Earth's surface, and we could also have chemical reactions that form it. All right, so if we look at our granite on the left and the gneiss on the right, how do they compare? If you notice, the gneiss is kind of a random pattern. And if you notice, I'm sorry, that was the granite, has the random pattern. And if you look over to the picture on the right, the gneiss has more of a banded appearance, which is characteristic of one of the types of metamorphic rocks. So granite actually becomes gneiss under extreme heat and pressure. So the picture on the left, under heat and pressure, will become the rock on the right. All right, so they form under extreme heat or pressure or both. It happens deep inside the earth. The appearance, texture, crystal structure, and mineral content changes. It can form from any other type of rock, including another metamorphic rock. So a sedimentary rock can become a metamorphic, igneous can become metamorphic. Metamorphic can go under more heat and pressure, become a different metamorphic. All right, so metamorphism happens if the rock is near magma, if it's deep underground, where tectonic plates will collide. That's a lot of pressure that happens there. And then we have recrystallization, which is a process in which crystals change in size and composition. All right, it's just showing you how some of the pressure can cause the banding in the surface of the rocks. All right, this just shows some of the parent rocks, metamorphic rocks. So like granite becomes gneiss, shale becomes slate, sandstone becomes quartzite. That's just a few examples. And our metamorphic rocks, we have two types. We have foliated, which is where our grains are in the parallel bands. So slate, schist, gneiss. And then we have non-foliated, which is where the grains are still pretty random. For example, that would be marble and quartzite. There shows a picture. You can see a foliated rock. You can see the bands. So just some rocks that turn into another type of rock. All right. So a difference between metamorphic rocks and igneous rocks, they both require heat. The igneous rocks will completely melt down and change into a whole new rock when it cools. The metamorphic rock, it goes under extreme heat and pressure and forms another rock. But so there's that, our sedimentary. These are the ones we are most common on Earth's surface, our sedimentary rocks. All right, sedimentary rocks also often have layers. They typically form underwater as the main place that they are formed, inside water, in lakes, rivers, whatnot. It has the layers, so if you look at the Grand Canyon, it has layers as well. We call that stratification, or strata. The layer is called a strata. So sedimentary rock is formed from sediment. Sediment is just loose material that comes from weathered rock and living materials. So just little pieces of rock and gravel. Formed in layers. Layers are not always visible. Sedimentary rock is the only rock type to contain fossils. That's a specific type of sedimentary rock. We'll go into that in a little bit. Some example of sediment will be shells and bones, mud and gravel, and sand and clay. Those are all sediments. All right. So like I said, it typically forms underwater. So first we have to have weathering and erosion occur, which remembers the breakdown and movement of rock. So as that is being moved, it falls down into layers. And with the layers, it settles, and then a new layer is added on top. And over time, some pressure occurs, pushing the layers together, and eventually, and we call this deposition, in which it is deposited, stops, and is dropped off. It eventually forms layers, and those layers can eventually turn into rock through cementation and compactation. So with sedimentary rocks, sand becomes a sandstone, gravel becomes a conglomerate, mud and clay can become shale. So compaction is when the sediment is pressed together and water is squeezed out. Somewhere we talked about how it's deposited into layers. The sediment through compaction is pushed together, and the water is eventually pushed out. And then, so that's pressure. And then we have cementation occur, which is when the dissolved minerals crystallize and glue the particles together. All right, so we can tell the different types of grain, getting coarse grained and fine grained. Coarse grain would be like a conglomerate right here with large pieces. You can see pieces of shell in that conglomerate and whatnot. And then all the way down to fine grained and shale where they're not easily visible. You'd pretty much need a microscope or something to help you enlarge the area and make it see the grains. All right, we do have three types of sedimentary rocks. The first one is called clastic, then we have organic, and we have chemical. Plastic sedimentary rocks, they're broken pieces glued together, like that picture when we had the coarse defined, the one on the far left, the conglomerate. That is a type of clastic rock. So it's broken pieces of other rock that got glued together. We need to look at the size of the pieces. So shale and sandstone are also examples. I mentioned the conglomerate. Conglomerate has to be more of a rounded edges to the rock. And then breccia has sharp edges. Organic sedimentary rocks, these are the ones that we can find fossils in. It's the only type of rock that fossils are found in. Organic sedimentary is from the ancient plants and animals, the remains of them. Coal is also an example of organic. It's remains of swamp plants over millions of years old. We also have limestone, which is formed from shells and skeletons of sea animals from a long time ago. They also contain like calcite and can contain the shells of oysters or shells of clams and other things. Chemical rocks, the third type, is essentially when we have evaporation occurring and the water dissolves away and the crystal is left behind. So, it evaporates and calcite comes out and is left behind, and that forms into limestone. Rock salt and gypsum form from evaporation in our drier climates. All right, so I was just looking through those questions. All right, so I'm going to show you one more thing if I can find it. Where is it? All right. So all these tie together with the rock cycle. So keep in mind, all rocks can turn into another type of rock, which we call the rock cycle. Remember, this rock cycle it's just a cycle and it never ends. It's like a big wheel. So every rock can turn into another type of rock. So an igneous can turn into a sedimentary or metamorphic or back into another igneous. In order to do that, it has to melt back into magma and then it has to cool. For rocks to become metamorphic, they have to undergo heat and pressure. Remember, a metamorphic rock can also go under more heat and pressure and become another metamorphic rock. And then all the rocks can become sedimentary through weathering and erosion for happening first. The rock has to be broken down. The sediments has to get moved. And then once it's deposited, compaction and cementation occur to create the sedimentary rock. So I just wanted to go over that picture. If you have any questions, feel free to send me a message on Remind and let me know. Hopefully this helps out for some of you. And hopefully be back in class soon. I miss seeing you guys. Have a good one.